Okay, so in this final part, what we're going to do is we're going to write some polynomials from zeros. Okay, so when we write polynomials from zeros, we can either write them in factored form, okay, which means that we're going to leave them in parentheses, or we're going to write them in the general form. So general form, which just means you're going to multiply it all out. So multiply all binomials. Okay. So here we go. So let's try our very first example. Okay. So we're going to, let's just write this one right in factored form. Okay. And here are your zeros. So x is equal to 3, 2, -1, and -1. Okay, so when we're writing our zeros, we want to make sure we know how we can got them. So we got x was equal to 3, we got x was equal to 2, x was equal to -1, x was equal to -1. So this used to be, kind of working backwards, the binomial x plus 1, x plus 1. And so what we can do is we can write them all together. Plus 1, x plus 1. Again, set that equal to 0. We see that we have two binomials written the same. So my final answer, because we want to make sure we write it as f of x, we can say x minus 3, x, let's say minus 2, and then x plus 1. And we can just write it as squared, or we can write them all out together. All right, so let's try another one like this. So we'll say example number 2. So here are our zeros. X is equal to 0, 0, 0, 4, and -4. And we'll still write this one in factored form. Okay. So again, what we're going to do is we're going to say x was equal to 0, x was equal to 0, x was equal to 0, x was equal to 4, x was equal to -4. Set this one equal to 0, we have the same one. This would have been x plus 4. This would have been x, minus 4. Around this one, minus 4, and this would be x plus 4 equal to 0. So this would be x, 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 x minus 4, x plus 4 equal to 0. So our final answer would be x cubed, x minus 4, and x plus 4. You can set that equal to f of x. All right, and let's do one more. And this time let's not do it in factored form. So this one will be a little bit more challenging. So we'll call this example 3. So write in general form. Okay, because not all of our zeros are going to be integers or rational numbers. So here are our zeros. So x was equal to 4, and then 2 plus root 11, and 2 minus root 11. So how we are going to deal with this. So again, if I set x is equal to 4, x is equal to 2 plus root 11, x is equal to 2 minus root 11. If you don't need us to do this step, you don't have to. So move all of this over. So notice that each time we move everything over to the other side, it becomes the opposite. So again, I get x minus 4, x minus 2 minus root 11, x minus 2 plus root 11 was equal to 0. Again, I'll set that equal to f of x in just a second. I'm going to go ahead and multiply those together first. So I'm going to use my area model. Oops. X minus 2 minus root 11. And then x minus 2 plus root 11. So x squared minus 2x minus 11, root 11x. Minus 2x, 4, and then a positive 2 root 11x, root 11x minus 2 root 11, and then minus root 11 squared, which is just going to give us a positive 11. Oh, sorry, negative 11. All right, so negative 11 is what I meant to say. All right, so I'm going to come back here. So this will be x minus 4, and then x squared. These will make you minus 4x. And then these will cancel each other out. These will also cancel each other out. And then 4 minus 11 should be negative 7. I'm going to go ahead and I'm going to change this. Well, I'm going to keep it equal to 0. That's fine. And I'm going to do this one more time. So set up my area model. So x minus 4, x squared minus 4x minus 7, x cubed. Oops. 16, and then positive 28. So go ahead and we are going to x cubed. We will get a minus 8. Oops. Let me write that a little bit better. Minus 8x squared, and then plus 9x plus 28. This time I will set it equal to f of x, because that is what we are doing. So notice that even when we multiply everything out, notice that our answer will never have a radical in it. Okay, and just FYI, these are conjugates, so 2 plus root 11, 2 minus root 11, and so when you multiply conjugates together, they will all disappear. Okay, and we can still graph this one. It would just be a little bit harder to figure out where 2 plus root 11 is 2 minus root 11 is.